A river has vanished, not through drought, not through the slow turning of geological time, but through the removal of a single small animal. We stand at the edge of what was once a living wetland, a place that filtered water, sheltered hundreds of species, held the land together through flood and drought alike. Now, silence. The trees stand dead. The fish have gone. The birds no longer come. The ground, once soft and dark with water, lies cracked and pale. No earthquake, no chemical spill, no catastrophe to point toward, just one absence. One removal, one quiet decision that nobody at the time believed would matter. But to understand what happened here, we must go back, before the disappearance, to see what was there. The beaver, Castor canadensis, in North America. Castor fiber in Europe. A rodent, heavy-bodied, flat-tailed, slow on land. By every superficial measure, unremarkable. And yet, they build dams from branches, mud, and stone. They flood small valleys. They fell trees with teeth perfected by 7 million years of evolution for exactly this purpose. They have been reshaping water, rerouting rivers, converting dry ground to wetland, longer than our own genus has walked the earth. Before European settlers arrived in North America, between 100 and 200 million beavers ranged across this continent. Their dams created a mosaic of ponds and flooded meadows so extensive that they defined the very hydrology of the landmass itself. The landscape those early explorers described, lush, improbably wet, fertile far into the interior, was, in significant part, a beaver landscape. Then came the fur trade. Within 2 centuries, the population fell to perhaps 100,000 animals. The wetlands began to drain. Rivers changed their course. The land dried in ways no one had language to explain. And scientists, looking back much later, realized they had inherited a continent fundamentally different from the one that existed before. Not through climate, not through geological change, through the absence of one animal. For most of the 20th century, the scientific view of beavers remained limited. Rodents, dam builders, occasional nuisances to farmland and drainage. Wildlife managers trapped and removed them when their flooding blocked culverts or waterlogged fields. The assumption was simple. Beavers were one piece of a complex puzzle. Important, perhaps, but replaceable. Ecosystems had absorbed losses before. They would adapt. Then, beginning in the 1980s, controlled field studies began producing results no one had predicted. When beavers were removed from a watershed, deliberately, carefully, the effects were not gradual. They were immediate. Dams collapsed, Within a single season, ponds drained, the water table fell, stream banks, held for decades by saturated soil, began to erode. Sediment settled over generations, washed downstream, clouding the water, suffocating the insects at the base of the food chain. Within a few years, fish populations declined. Not slightly, significantly. In some studies, 75% of native fish species disappeared within a decade of beaver removal. The birds ceased to nest along the water's edge. The amphibians, frogs, salamanders, lost the slow, shallow pools they required to breed. The insects vanished. The trees dried. Meadows kept green by subsurface water, browned by July. Scientists had assumed an ecosystem could absorb the loss of one species. What they found was something else entirely. Not a gap in the system, a collapse of the system. And yet, that was only what could be seen. Beneath the surface, in the hydrology, the soil chemistry, the water table itself, something was happening. The models had not been built to predict at all. Water moves through landscape in two ways: across the surface, in rivers, in streams, in channels cut by 1,000 seasons of rain, and slowly, invisibly, through the soil itself, through aquifers, through root systems, through deep, saturated earth that holds moisture across months, across decades. Beaver dams do not merely create ponds, they force water sideways and downward. They recharge the groundwater. They fill aquifers that release their stored water across weeks, months, years, long after the last rain has fallen. A landscape with beavers stores water, quietly, invisibly, in the earth itself. A landscape without beavers exports water, fast, downhill, into rivers now erratic, floods higher after rain, drought more severe between storms. The sponge has been removed. What remains simply drains. Research by ecologist Emily Fairfax, published in the early 2020s, revealed something startling. Areas around active beaver ponds remained green and wet during wildfire season, even as the surrounding landscape burned. The subsurface water, held in place by generations of beaver engineering, was protecting the land against fire. Not as side effect, as structural function. Remove the beavers, drain the ponds, and within years, the same land burns. The researchers, hydrologists, ecologists, conservation biologists, described a consistent experience. They had known, intellectually, that beavers mattered, but the speed and totality of degradation after removal was something else entirely. One ecologist stood at the edge of a stream that had been a pond the previous decade. Dry streambed, cracked mud, silence. And for the first time, they had to ask a question found in no textbook. Not what the beaver was doing for this ecosystem, but what this ecosystem actually was without it. Here is what few know. The disappearance was not natural. Not climate, not disease. It was a commercial decision, made repeatedly across 3 centuries by industries that understood the value of beaver pelts and nothing else. Beaver fur, specifically the dense, felted underfur, drove the North American and European fur trade from the early 1600s through the mid-1800s. Hats, coats, trimmings for European aristocracy who would never see a living beaver. The demand was enormous. The supply appeared infinite. By the time it became clear that 150 million beavers could, in fact, become 100,000, the wetlands were already draining. Nobody calculated it. Nobody sat in a room and decided to remove the Keystone species from a continent's water system. They simply did not think about it. The beavers were raw material. The landscape was backdrop. What happened to the backdrop when the raw material was gone was not a question anyone asked. But the consequences accumulated. Wetlands that had existed for thousands of years, created, maintained, expanded by successive generations of beaver colonies, dried within decades of the animal's removal. Rivers that ran clear and cold through natural filtration ran silty and warm. Springs that had persisted through the driest summers, fed by aquifers the beavers had quietly recharged for millennia, began to fail. Historians studying the American West have noted something striking in early settler records. Land described as arid, difficult, prone to drought, land that drove settlers to ruin, had been described by explorers just decades earlier as well-watered and rich. The difference was not climate. The difference was the beavers, already trapped out before the settlers arrived. They inherited a broken landscape and assumed it had always been broken. This is not the story of one river. It never was. What this animal maintained across a continent was not ecological. It was infrastructure, the water system entire civilizations settled around without ever knowing what they depended upon. Consider for a moment the systems in your own life that you cannot see working. The infrastructure unnoticed until it fails. Those who absorb problems before they reach you, quietly, constantly, without recognition, understood only in their absence. The beavers were that, for an entire continent's water system. 7 million years of engineering, invisible, constant, taken so completely for granted that when removed, those who removed it did not even know what they were dismantling. Grief is loud. Appreciation, in the moment, is almost always quiet. The beaver ponds were quiet for thousands of years. The water was simply there. Rivers ran clear. Springs held through August. Fish were abundant. Meadows stayed green. And then, one by one, they were not. We inherited a diminished world and called it normal. We studied the diminished world and called it baseline. We built our science of ecology on a landscape already invisibly broken. And yet, what is happening now in valleys across 3 continents is not what most researchers predicted. The beavers are returning. Not everywhere, not fast, but in Scotland, in California, in the American Southwest, in Germany, the Netherlands, the Iberian Peninsula, conservation programs have begun reintroducing colonies to landscapes that have not seen them in centuries. The results are consistent. Within years, sometimes within a single season, ponds begin to form. The water table rises. Springs return to land dry for decades. Fish populations recover. Bird species absent for generations return to nest along edges that are wet again. In the Methow Valley, Washington State, researchers documented stream ecosystem recovery with a precision that surprised even those who designed the study. Species they had not expected for decades were present within 5 years. The land had not forgotten how to be wetland. It had simply been waiting for the engineer to return. Scientists still do not fully understand the speed of this recovery. The resilience encoded in these landscapes, wading through 40, 60, 100 years of dryness, exceeds what models predicted. The system, it seems, is more patient than we are, more durable than we imagined, simply waiting for a small, flat-tailed, unremarkable animal to return and do what it has always done.